Hello, I'm Alison Svrcek with StormGeo. I'm the Global Director of Client Services, Business Continuity Manager for StormGeo's Houston office, and I'm also a meteorologist with 14 years of experience in the industry. Every year, companies are faced with many risks and must deploy risk mitigation strategies in order to safeguard employees and protect assets. This presentation will dive into why you need more than just a simple weather forecast. In this presentation, I'll be covering the following topics: understanding, assessing, and responding to risks due to weather impacts. I'll also give a review of the 2019 historic hurricane season, including Hurricane Dorian, as well as the outlook for the 2020 Atlantic hurricane season. Now, StormGeo is a global organization with 24 offices and 8 operations centers. We have over 500 employees and provide services to clients 24/7/365. The primary industries that we service include shipping, renewables, cross-industry, oil and gas, and media. Now, this is a snapshot of our Houston office operations center, where forecasters provide weather intelligence to clients around the clock. Let's start by addressing the sheer volume of weather's impact to businesses. Weather is the major cause of disruption to businesses globally. As you can see in this graphic, these are losses due to natural events between 1980 to 2018. Between the 2017 and 18 years combined, over $653 billion in overall losses were due to natural disasters. Now, weather's impact on business disruption is also depicted in this graphic that shows from about 1980 to 2018 a significant increase for meteorological, hydrological, and climatological natural events. Now, in 2017, we tallied 16 total billion-dollar catastrophes for a staggering $319 billion in losses. This, of course, includes Hurricane Harvey, which affected the Texas coastline, but also includes Hurricane Irma that went up the Florida coastline, Hurricane Maria, which devastated Puerto Rico, as well as many wildfire outbreaks across California, and also severe weather outbreaks across the Midwest. 2018 billion-dollar catastrophes tallied up to about 14 for about $93 billion. And in 2019, similar number of events, total billion-dollar catastrophes, totaling about 45 billion US dollars. Taking these staggering numbers into consideration, these are due to geophysical events. Where do you begin? Acknowledge that there is a lot of disparate information out there. We see it every day on social media platforms, etc. Now, understand the difference between weather hype and professional scientific straight talk. You want to be aware of the possibility of over or under alerting, create actionable plans based on site-specific weather data, and lastly, keep in mind where your liability lies and how to implement a duty of care solution to help safeguard your employees. Next, we'll talk about assessing risks of weather impacts. When assessing business risk, understand the fundamental interdependencies within your organization. What is your risk tolerance? Do you have operational awareness? Define specific operational timelines when preparing to respond to an event. Make note of which types of events are most likely to impact your organization the most. Severe weather, is it flooding due to heavy rainfall, hurricanes, wildfires, even snow or ice storms? Now, when analyzing risk, take into account the probability of occurrence as well as the potential severity. Most impacts are due to power outages from storm events, and these can be categorized during spring severe weather system and also with a secondary impact towards the fall severe weather season. The most significant risk to businesses can occur with events that have a relatively low probability of occurrence, but an increased severity. These would be hurricanes such as Hurricane Harvey, Hurricane Katrina, Hurricane Ike, etc. Simply stated, as the probability of impact increases and the severity of the impact increases, an organization's potential for unmitigated loss goes up tremendously. Take into account at an early stage the cost of mitigating action versus the effectiveness of mitigating action. As the saying goes, an ounce of prevention is worth a pound of cure. Next, we'll dive into responding to risks of weather impacts. Now, time-phased business risk response approach is what we like to deliver. Determine when a decision can be made that improves your resilience. How long will it take you and your employees to evacuate? How long does it take to transfer operations to an alternate work location? Determine what other actions can be taken. It's best to start with uncomplicated things and move through time towards more impactful options. Now, there are 3 primary risk response phases: assessment, communication, and mitigation. For business as usual, daily monitoring of weather threats helps you keep primary stakeholders informed. You can make clear communications to stakeholders and make preparations for risk mitigation. In the awareness phase, routinely assess weather hazards and understand the outlook for employee safety and asset protection. Continue business as usual protocols and communications. For monitoring, keep an awareness of long-range and short-term threats. Begin to involve management and HR. Notify your incident command task force, all while continuing the business as usual protocols. Review operational schedules for potential modification and stand at the ready to communicate changes. For preparation, a significant threat has been identified. Your incident management team is activated and meeting at regular intervals, activating early stages of your hurricane response plan. Keep management, HR informed and involved in the process. Contact your disaster assessment team to notify them of potential deployment after an event. Make final preparations for the onset phase. As the significant weather event is underway, continue monitoring from a safe place. Continue to meet with the incident management team to prepare for post-event actions. Communicate with employees about the company's response to the event and any actions they should be taking. Be ready to deploy post-event assessment teams after the event has passed. Now, post-event, deploy your assessment teams, implement employee assistant programs, keep management informed, execute modified schedules as necessary, and begin the recovery phase of your response. In conclusion, it's best to understand weather impacts to your business, assess continually the risks of impacts, respond optimally to the risks of impacts, and utilize time-phased tools. Now, let's dive into the 2019 hurricane season review and the 2020 hurricane season outlook. For 2019's review, here's a nice picture of Hurricane Dorian as it approached the Bahamas. Now, StormGeo's 2019 forecast is shown here. As you can see, we show you what the normal number of named storms would be. That's about 14 and 7 hurricanes with 3 intense hurricanes. Now, last year we were leaning towards an average season. Our forecast had very similar numbers to the normal averages, but what actually occurred was an above average season with 18 named storms, 6 hurricanes, and 3 intense hurricanes. However, the 2019 season, of course, it did have the above normal activity, but several of the storms, named storms, were very weak and very short-lived, and we'll go into those storms here in just a bit. In the 2019 season, 7 of the 18 named storms lasted 24 hours or less. Only 3 hours for Tropical Storm Imelda, which came into the upper Texas coastline. 2 of the 6 hurricanes lasted less than 12 hours, and that was only 1 hour for Hurricane Barry. Now, Hurricane Barry was a brief pop-up hurricane that moved into the mid-Louisiana coast on July 13th. There were no deaths reported about Barry, although it did produce about $600 million in damage. Now, pop-up hurricanes develop in the Gulf of Mexico about once every couple of years, every 2 years or so. Most pop-up hurricanes impact the Gulf lease areas offshore. Now, pop-up hurricanes are those that originate in the Gulf of Mexico or the northern Yucatan Peninsula and become hurricanes in the Gulf prior to landfall. 40 of these types of storms have developed into hurricanes formed in the Gulf of Mexico over the last 80 seasons, and this includes Hurricane Barry in 2019. Now, Barry was unique because it formed from a non-tropical weather feature identified across southwestern Kansas in early July. On 3 p.m. Monday, July the 8th, we issued our first advisory on Disturbance 12. We predicted it to move inland into southeast Louisiana around noontime on Saturday. This is our first advisory, and this is our 20th advisory right about landfall at 9 a.m. on Saturday. So not a bad forecast. Now, the strongest hurricane of 2019 was, of course, Hurricane Dorian. It was a Category 5 with 185 mile-per-hour winds as it struck the northern Bahamas on September the 1st. And this picture in the lower left corner is actually a picture from inside the eye wall here in Hopetown, Elbow Key, and Abaco Islands, Bahamas. Now, Dorian is one of the strongest hurricanes ever to make landfall in the Atlantic Ocean. Its type refers with the Labor Day hurricane of 1935 in the Florida Keys. Now, it's possible that the Great Labor Day storm of 1935 had stronger winds than Dorian because it did have a lower pressure and a little bit smaller size, but we had no way to measure such wind back in the 1930s. We initiated advisories on the morning of August 24th. The initial Day 7 track guidance indicated Bahamas and Florida threat. But on Saturday, August 31st, nearly a week later, the models finally came into good agreement that Dorian would track to the east of Florida. As you can see, the plot of all the model guidance at that time kept it just hugging the coastline and staying out to sea. Now, Tropical Storm Imelda formed on September 17th and lasted fewer than 6 hours. Imelda was upgraded to a tropical storm as the low center moved into the Texas coast near Freeport. It was downgraded to a depression only 6 hours after being named. Now, Doppler radar estimates for Tropical Storm Imelda are around 44 inches of rainfall in Fannett, Texas for Imelda. Now, this is an interesting graphic because it compares the rainfall from Imelda to Hurricane Harvey just 2 years prior. The aerial 4-day coverage of heavy rain was far less for Imelda than it was for Harvey. And as you can see, Imelda was no Harvey. The aerial coverage of the heavy rainfall for Harvey was much, much more across the Houston, Galveston, and Beaumont, Port Arthur areas. I mean, all the way down at the mid-Texas coast. And of course, this is only a 4-day accumulation of precip. The event for Harvey was actually 5 days, with some of these higher totals of rainfall approaching 60 plus inches for Hurricane Harvey. However, if you happen to be in this area during Tropical Storm Imelda, the impacts were no less. Olga was declared a tropical storm by the National Hurricane Center on October 25th, just before it moved inland. It lasted less than 6 hours as a named storm. Olga was also classified as a tropical storm as it moved inland, very similar to Imelda. However, it was more of a frontal low pressure center than a tropical storm. The band of clouds across the Gulf is actually a cold front. Toward the end of the season, the National Hurricane Center began naming formerly non-tropical lows in the far northeast Atlantic. Now, such lows as these would not likely have been classified and named in the past. All right, moving on to the 2020 hurricane season overview. There's some factors to consider for this year. Water temperatures in the tropical Pacific. Are we facing an El Nino or a La Nina? Water temperatures in the deep tropics of the Atlantic. The Atlantic Multi-Decadal Oscillation, also known as the AMO, and the strength of the Bermuda High. And lastly, we'll go into the analog seasons before producing the forecast. Now, sea surface temperatures in the tropical Pacific have been above normal for the past 2 seasons. However, there are indications that this may be coming to an end for this year. Now, will there be an El Nino in the Pacific this season? An El Nino occurs when tropical Pacific waters warm. This increases hurricane activity in the Pacific, but limits activity in the Atlantic. Water temperatures there were above normal for the past couple of seasons, but the temperature trend is definitely downward. That's cooler for this year. Early indications are that water temperatures in the tropical Pacific will lean towards cool or neutral. None of the models are forecasting an El Nino to fully develop, and such water temperatures would not significantly hinder hurricane development. An El Nino would produce increased wind shear across the Atlantic basin, limiting hurricane formation. However, that is not being predicted for this year. Now, currently water temperatures are above normal across much of the Atlantic basin. Warmer water could mean more heat energy available for stronger hurricanes. It's very early to make any conclusion about oceanic heat content in the peak of the season, but early indications are that the oceanic heat content is much higher in the central and western Caribbean than the same date in 2019. Notice the really warm temperatures here in the southern Caribbean. And this is a snapshot from this date and time, the same date exactly 1 year ago. Now, the Atlantic Multi-Decadal Oscillation is another factor that we look into to determine the possibility of an active hurricane season. I won't go into very specific detail about this, but basically what you need to understand is that over a period of decades, warm water in the northern Atlantic will melt. It will then reduce the current flow. The salinity of the water will drop, will reduce the current flow, leading to a cooling or slowing of the warm current. And over decades, when this happens, more ice forms, increasing the salinity, and the current flows faster, melting the ice yet again. The Atlantic naturally warms and cools over periods of years, so 25 to 40 years. And on average, a warm cycle is known to produce about 4 major hurricanes in any given season, while in a cool cycle, only about 2 are expected to develop. Now, we feel like the Atlantic has shifted to a cool cycle starting at about 2013. However, the AMO, the Atlantic Multi-Decadal Oscillation, is weighted heavily towards the northern latitudes where the water is currently very cool. Typically, when water is this cool up north, it's also cool between Africa and the Caribbean, but this is not the case this year. It is much, much warmer. Now, the North Atlantic Oscillation can also suggest where storms may form and track. We are looking at the possibility of a positive NAO this season. What that means could mean a stronger Bermuda High, more low-level wind shear east of the Caribbean, and cooler water east of the Caribbean. Warmer water along the southeast U.S. and in the Gulf of Mexico, which is definitely what we're seeing. Less hurricane activity in the subtropics. That's the area that's much further away from the coastal U.S. And more activity in the Caribbean and Gulf of Mexico, and possibly into the southeast United States coastline. Now, the European model seasonal forecast for June through August is for near normal rainfall in the deep tropics. The same area has had below normal rainfall for the past 2 to 3 seasons. It may be more favorable there for hurricane development this season. Now, this is the updated set of analog years for April, which do favor a more active hurricane season. A few years to note here, we've got 2001, we had Tropical Storm Alison, which wreaked havoc on the Houston-Galveston area with very significant flooding back almost 20 years ago. In 2008 was Hurricane Ike, another storm, another hurricane Category 2 that struck the Houston-Galveston area. And in 2016, Hurricane Matthew went along the east coast of Florida. However, did not make a direct landfall in Florida. It did scrape the coastline and did result in some very heavy rainfall across Georgia and the Carolinas, which also led to some flooding. As you can see, the average number of named storms across these seasons is close to 15, with 8.3 hurricanes, 4.8 intense hurricanes. During these analog seasons, you can see the number of hurricanes and tropical storms plotted on this graph here, on this map here. A few that I've mentioned, of course, were Hurricane Ike. Also in the year of 2008 was Hurricane Gustav, which of course affected many people across southeast Louisiana. And we also had, let's see, Matthew was in 96. We also had the Matthew I was just speaking about in 2016. And another one from 2008 was Hurricane Dolly, which went into the very far south Texas coastline. So what we're looking at is the possibility of a high incidence of storms across Cuba and the southern Yucatan Peninsula. Now, the signals that may point to a more active season versus a less active season, we'll go through those here. Less active season, we could see a cool phase of the Atlantic multi-decadal oscillation, but at this point, it's still questionable. Factors that are pointing to a more active season: there is no El Nino that is predicted for this year, above normal water temperatures and oceanic heat content in the tropical Atlantic, Caribbean Sea, and the Gulf of Mexico. And our analog years support an active hurricane season. And lastly, the National Hurricane Center has had a more liberal naming convention over the last several years. So it's likely that we're going to see above average amount of activity for the 2020 hurricane season. We'll go into the latest soil moisture anomaly. We could see a trough axis setting up over the east central U.S., which could potentially direct storms to the northeast Gulf of Mexico and into the southeast United States. Now, our 2020 forecast is for above normal activity. Again, here's a list of the normal number of storms, which is 14, 7, and 3. Our forecast for this year has about 16 named storms, 8 hurricanes, with 4 intense hurricanes. Now, what we're showing here are the normal areas, risk areas that are in normal, including the Caribbean islands from the Dominican Republic, Puerto Rico, all the way down the chain. Also for the northeast U.S., the mid-Atlantic, as well as parts of of Central America, where we're forecasting above normal amount of activity could be all along the Gulf of Mexico, from around south of Tampico, the Bay of Campeche, all the way up the southeast Texas coastline, as well as all the way across the Gulf and up the coast across Florida and the coast of the Carolinas. So we're more likely to see storms that will develop in the Caribbean Sea, the southern Caribbean Sea, as well as the Bay of Campeche and Gulf of Mexico, and head towards the southeast U.S. coast. And so for this year, this is the list of the names for 2020. It's the same list that we had in 2008 and 2014. 3 of those storms from that year have been replaced. So that year we had Gustav, Ike, and Paloma. Those were replaced with Gonzalo, Isaias, and Paulette. Isai is interesting, has an interesting pronunciation. It was not reached in the 2014 hurricane season, so this might be our first year to actually see a storm named with this particular name. All right, well, that wraps up my presentation. Thank you so much for listening. And again, my name is Alison Svrcek with StormGeo. Feel free to reach out and contact me if you have an interest in StormGeo services. And I thank you for listening. Bye-bye.